These are your Unit 5B Day 11 notes. In this video, we are going to focus on Standard 1A, Standard 1B, and Standard 3A. You are going to be given real-world scenarios, and you are going to determine the slope-intercept and either graph or write a slope-intercept equation. Here's our first situation. Nancy was trying to save money to buy a gift for her friend's birthday. She started with $2, and each day she was able to save $3. Okay, so I know that I'm going to have to graph this, and the graph needs to be labeled. So I need to determine the relationship right here, and I can see that she is saving money. So she started with $2, and then each day she was able to save $3. So I'm comparing days to money. How much is Nancy saving each day? Remember, our unit of time is always our X. So we have days here, and we have dollars here. Perfect. Now that I set up my graph, I'm going to determine my Y-intercept and put it on the graph. My Y-intercept is my starting point, and if we look right here, it says she started with $2. Her beginning, her starting point, that's the Y-intercept. So when X is 0, at 0 days, she already has $2 in her pocket. Now, my next thing is to determine the slope, and I'm going to put the ordered pair for the Y-intercept over here, 0, 2. All right, now when I determine the slope, that is the rate of change, that is the pattern, that is what's happening over and over again. And remember, this each is a clue that it's happening every time, each time, over and over again. That is your slope, your rate of change. So each day she was able to save $3. So your slope would be 3 over 1 because she saves $3 per day. Change in Y, my dollars, is 3 over my change in X, which is days, 1. So 3 over 1. Now that I know my slope, what I'm going to go ahead and do is I'm going to plot another point on my graph. My slope is 3 over 1. The rate of change, $3 every day. So up 3, 1, 2, 3, and then over 1. So my next point would go right there. And if I want, I can just keep following that pattern and plot more points. So 1, 2, 3, 1, and so on. 1, 2, 3, 1. All right, so the rate of change, what's happening over and over again? She's saving $3 per day. So now that I have I've labeled this, I have my points, I can go ahead and draw a line that represents the slope or rate of change. All right, I'm going to graph the linear relationship given this verbal representation, just what I did on the other side. I'll do one more example and then you do the last two on your own. Karen has $8 in her bank account. She withdraws $2 each week. So the first thing I need to do is determine my relationship. And I can see that I have dollars, $8, $2 each week. Remember that each kind of helps us find that relationship, identify what's going on, what's happening every time. So now that I've figured out what two things I'm comparing, dollars and weeks, I'm going to go ahead and label my graph. I know that my independent variable, or my time, is always on the x-axis. So I have weeks here and dollars here. Now that I've labeled my graph, I'm going to identify my Y-intercept. Y-intercept is my starting point. Well, she has $8 in her bank account, so she's starting with $8. So my intercept is 0, 8. So that means when X is 0, Y is 8, and that is my starting point. I put that on my graph. Next, I'm going to determine my slope. It says $2 each week, each. Rate of change happening over and over again. What's happening over and over again? It is $2 each week. Now the next thing you need to pay attention to is what it says ahead of this. It says withdraws. If you're withdrawing something, you're taking it out. There's less money. So that means she's withdrawing $2 each week, which would be a negative rate of change. Her money is not increasing, it's decreasing because she's withdrawing it. So my slope is -2 over 1. So down 2 over 1. That would be a point on the graph, down 2 over, down 2 over 1, 1, 2 over 1, down 2 over 1. And then I'll connect those lines, pretend that's a beautiful straight line because I clearly am not very good at that. All right, go ahead and try the next 2 on your own. Okay, hopefully you tried these 2 on your own. So for this one, we are comparing pizzas and cost. All right, there's a delivery fee, which is a one-time thing. You start with that amount. You got to pay $3 right off the bat. So that's your Y-intercept right here. Next, each pizza costs $5. So each pizza, remember there's that clue word that it's a rate of change. So every time you buy a pizza, it's $5. So up 5 over 1, up 5 over 1. My slope is $5 per pizza, right? And pretty much something, you know, when we were saying that time always goes on your x-axis, dollars pretty much always just goes on your y-axis too. So if you're trying to figure out which one is independent and dependent, the cost is dependent on what you get. So that's why the cost is your y-axis, because remember your y-axis is your dependent variable. Okay, moving on to the next one. We're comparing books and weeks. She starts with 3 books. That's my y-intercept. And then she checks out 3 books every week. Here's my key word, 3 books every week. So that means my slope is 3 over 1. Every week she gets 3 books. So the slope is 3 to 1, up 3 over 1. And that is represented with this line. All right, hopefully you got these correct. If not, go ahead and find your mistake and fix it. Okay, now we are going to identify the intercept, the slope, and create a y-intercept equation. Now remember, our y-intercept equation is y equals mx plus b. M is our slope, and b is our y-intercept. So we're not going to start with this problem. We're going to look at this problem down here. So first thing we need to do is highlight our key information. Kelly opens a bank account with $100. She deposits $25 per week. So again, we're trying to find that relationship so we know what our slope is. So we can see that we are comparing dollars to weeks. Okay, so she starts with $100 and she deposits $25 per week. My next step is to determine if I need to make a table if needed. So we only need to make a table if it gives us more than one comparison. But if it already tells you what it is every week or per day, then you don't have to make a table. So if I look right here, as she opens a bank account with $100, so I know my starting point, that's my y-intercept 0, 100, and then it says she deposits $25 per week. Well, my slope is 25 over 1 then, because it tells me what's happening every single week. My rate of change is 25 over 1. I don't have to find a table to see what the slope is because it straight up tells me. I don't have to look at multiple comparisons or relationships between money and weeks because it tells me what the pattern is. It's happening $25 every week. And then my last thing is to set up my equation, and we know that the equation is y equals mx plus b. So now what we need to do is just put in our m and put in our b. So y stays the same. Y is equal to m, which is my slope, and my slope is 25 over 1. So I'll just write this as 25. If you wrote it as 25 over 1, it wouldn't be wrong. 25x plus b, which is my y-intercept. And my y-intercept is 0, 100. That's my ordered pair. So I write this as simply 100. So Kelly opens a bank account with $100. She deposits $25 per week. This equation, y equals 25x plus 100, represents this situation. All right, let's look at another one. Kelly opens a bank account with $100. After 2 weeks, she has $150. After 4 weeks, she has $200. So this problem is similar, but a little bit different. First of all, we can see we're still comparing dollars to weeks. But here, we can see that there are two different scenarios. So we have 2 weeks and 150 and 4 weeks and 200. So we know we have to make a table because it doesn't say, hey, this is what's happening every week. It says this is what's happened at 2 weeks. Here's what happened at 4 weeks. Now you figure out what the average is, what's happening over and over again, okay? But first we'll start with our Y-intercept. She starts with $100. Okay, that's her starting point, same as the other equation. And so we'll put that in. My Y-intercept is 0, 100. Next, I need my slope. Now, because I have more than one comparison, I'm going to need to make that table. Okay, so I set up the table. We're comparing weeks to dollars. We know weeks is always going to be our independent, or X. So weeks is right here, and dollars is here. Now, and I set it up for, we start at 0 weeks with $100, then 2 weeks, $150, then 4 weeks, we have $200. Okay, now that I've set up my table, I'm going to find my rate of change. Same thing we've been doing for a while now. So we have 200 minus 150, and that is equal to 50. So my change in Y is 50. Next, I'm going to look at my change in X. So I have 4 minus 2, which is equal to 2. So my change in X is 2. So my slope is 50 over 2, which would mean $50 every 2 weeks, but I want to know what it is per one, and that can be simplified to 25 over 1. So my slope is 25 over 1. My last thing is to put this into an equation. So we have Y is equal to mx plus b. That's our equation. Well, our m is our slope. The m is our slope. And our slope we determine is 25 over 1. So this is going to be Y is equal to 25x plus b, and b is my Y-intercept. My Y-intercept is 0, 100, so this will be plus 100. All right? So you can see that the equation for this scenario is y equals 25x plus 100. These two situations are very similar. The difference is, you guys, that here they told us what it is per week, and then here we had to figure it out. Same situation, but our slope was not given straight up here, not 25 per week. We had these different scenarios. We had to compare them to figure out that 25 per week. Okay, I would like you to do these next 3 on your own. Remember, if you have multiple comparisons between your 2 items, you're going to have to make a table. If it tells you what's happening each week, for example here, each week, we already know that our slope is going to be 5 over 1 because it tells us what's happening every time. Okay. Hopefully you tried these on your own and you got the same equations. All right, so we have y equals 2x plus 4. The change in y, you guys, over here was 10, and the change in x was 5. 10 over 5 is simplified to 2. That's where that comes from. So y equals 2x plus 4. This one, y equals 150x plus 200. And this one, y equals 5x plus 150. This one, even though it says every 2 hours, it doesn't, even though it isn't per one, there's only one comparison. So it's saying the slope is 300 over 2, and then you can simplify that to 150 over 1. All right, so if you did not get these answers, you guys pause the video and look through each step and determine what you did wrong. All right, I'll see you tomorrow.